Use Gauss-Jordan elimination to solve the system x plus y minus z minus w equals 6, 2x plus z minus 3w equals 8, x minus y plus 4w equals negative 10, and 3x plus 5y minus z minus w equals 20. This is a 4x4 system of equations. It's a system of 4 equations with 4 variables. And we're going to use generally the same methods that we've been using for 3x3s, but I have to warn you, this is going to have a lot more steps, it's going to take more time, and it's going to be a little bit more complicated. Let's start by writing the augmented matrix that corresponds to this system of equations. To save time, I've just copied this into the augmented matrix form. Now here, our goal is going to be to get zeros in the lower left-hand corner, but we're going to be looking at more of them, and then to get ones along the diagonal. And then after we've done that, to get zeros above the ones on the diagonals. So it's effectively the same sort of process, but because we're looking at a larger matrix, we're going to have more zeros and ones. So first, I want to start by getting zeros below the 1 in the top. We've already got a 1 up here, which is really nice. Now we want to get zeros below it. So because we are already happy with the first row, we're going to copy that in our next matrix because that one's not changing. But now our goal is to get zeros below that first one. So to turn this 2 into a 0, what we can do is we can multiply the first row, row A, by 2, and then we can subtract row B from that. So we've got 2 times row A minus row B. When we do that, 2 times 1 is 2, and 2 minus 2 is 0. In the next column, 2 times 1 is 2, and 2 minus 0 is 2. Then 2 times negative 1 is negative 2, and negative 2 minus 1 is negative 3. In the next column, 2 times negative 1 is negative 2, and negative 2 minus negative 3 is the same as negative 2 plus 3, which gives us 1. And then in the last column, 2 times 6 is 12, and 12 minus 8 is 4. Next, we want to have a 0 down here in the third row. To change this to a 0, what we can do is take the first row, row A, minus the third row, row C, and then 1 minus 1 gives us the 0 that we need. So here we're going to take A minus C. When we do that, 1 minus 1 is 0. 1 minus negative 1 is 1 plus 1, which is 2. Negative 1 minus 0 is negative 1. Negative 1 minus 4 is negative 5. And 6 minus negative 10 is the same as 6 plus 10, which is 16. Then lastly, we need to get a 0 in the very bottom. To do that, we can take 3 times row A, that's 3 times 1, which is 3, and then subtract row D from that. 3 minus 3 gives us the 0 that we need. So we've got 3A minus D. Let's look at what that gives us in the other columns. 3 times 1 is 3, and 3 minus 5 is negative 2. 3 times negative 1 is negative 3, and negative 3 minus negative 1 is negative 3 plus 1, which is negative 2. Negative 1 times 3 is negative 3, and again, negative 3 minus negative 1 is negative 3 plus 1, which is negative 2. And then lastly, 3 times 6 is 18, and 18 minus 20 is negative 2 as well. So we are at the point where we've got zeros in the first column Next, we're going to want to have 2 zeros in the bottom of the second column. So we want to accomplish this, and we're not going to change the first 2 rows in the next step, so we can simply copy them. That's a 3. And then our goal is to end up with zeros here and here. To get a 0 here, we can actually take the second row, row B, and the third row, row C, and take the difference. We can do B minus C, or we can do C minus B. It doesn't really matter. So let's do B minus C. If we do that, 0 minus 0 is 0. 2 minus 2 is 0. Negative 3 minus negative 1 is negative 3 plus 1, which is negative 2. 1 minus negative 5 is 1 plus 5, which is 6. And then 4 minus 16 is negative 12. So that gives us a 0 here. Now we need a 0 at the very bottom. And the quickest way I can see that is by taking rows C and D and adding them together, because 2 plus negative 2 is 0. So here we're going to do C plus D. And so we've got 0 plus 0 is 0. We've already done 2 plus negative 2 is 0. Negative 1 plus negative 2 is negative 3. Negative 5 plus negative 2 is negative 7. And then 16 plus negative 2 is 14. So at this point, we've got even more zeros. And now we need this negative 3 to also turn into a 0. Now at this point, it's going to be challenging to do this as it is, because the only thing we can do to row D to change it is use row C. Because if we use rows A or B, there's going to be some non-zero numbers up here that are going to go down here and change the zeros that we've already built. So we can only deal with rows C and D without changing these zeros out front. And negative 3 is not a multiple of negative 2 or even positive 2. And so this 2 is a little bit problematic. But all of the numbers in this row are divisible by 2 or negative 2. So what we can do is we can divide this row by negative 2, and that's going to put a 1 here, which is going to make things easier for us in a couple of different ways. So for this step, all we're doing is taking the third row, row C, and dividing it by negative 2. So the other rows are going to stay exactly the same, but we'll take all of the entries in row C and divide them by negative 2. So we've got 0 and 0. Negative 2 divided by negative 2 is 1. 6 divided by negative 2 is negative 3. And negative 12 divided by negative 2 is positive 6. All right, this is going to be helpful because now it'll be a little bit easier to turn this negative 3 into a 0. What we can do is we can take row C, multiply it by 3, and then add row D. So the first 2 rows are not going to change at all. 1, 1, negative 1, negative 1, 6. 0, 2, negative 3, 1, 4. In fact, the third row isn't going to change either. But for the fourth row, we've got to take 3 times row C and then add it to row D. If we do that, 3 times 0 plus 0 is 0. The same thing happens for the next one. 3 times 1 is 3, and 3 plus negative 3 is 0. 3 times negative 3 is negative 9, and negative 9 plus negative 7 is negative 16. And then 3 times 6 is 18, and 18 plus 14 is 32. Okay, we are nearing 10 minutes, and we're almost kind of sort of hopefully to the halfway point of this problem. Like I said, these problems just take a long time. Now I want to point out what we've got that's good. We've got zeros all down here. We've also got a couple of ones on the diagonal. We're going to want this to become a 1, this negative 16. That's going to be next. And then afterwards, we're also going to be building zeros up here. And this 2 we also want to become a 1. We don't want to turn the 2 into a 1 right now because doing that would require dividing by 2 and we would end up with fractions. So we're going to save that for a little bit later. For right now though, the simplest thing we can do is to turn this negative 16 into a 1 by dividing that last row by negative 16. We're not changing anything in the other rows, so those will stay the same, but our row D is going to be divided by negative 16, which gives us 0, 0, 0, 1, and negative 2. All right. At this point, we can go through and we can change these 3 to zeros, and then after that, we can change these to zeros, and then we can continue changing this to a 1 and this to a 0. Let's go through and do the next step. In this case, we're actually going to leave the bottom row unchanged, and we're going to change the other 3 because we want all of the things above this 1 to become zeros. So for each of these, for rows C, B, and A, the only thing we can do to alter them is add a multiple of D, because if we add any of the other rows, we're going to get all of these extra numbers in front, and we don't want those. So for each of these, we're going to start with the row that we've got, and then we're going to add or subtract a multiple of this last row to cancel out what these are. So for row A, we've got a negative 1, and if we add row D to it, negative 1 plus 1 is 0. So we're going to add D to that. And then for the second row, row B, we've got a 1. To turn that into a 0, we can subtract row D. So that's going to be minus D. And then here we've got negative 3. To turn that into a 0, we can add 3 times that last row. So plus 3 times D. And that's going to give us what we need next. It's going to give us those zeros. I'm going to do the first row, and then I'm not going to go through the rest because this video is already so long. So for the first row, A plus D, 1 plus 0 is 1. 1 plus 0 is 1. Negative 1 plus 0 is negative 1. Negative 1 plus 1 is 0. That's that 0 we wanted. And then 6 plus negative 2 is 4. We can do similar row operations for the next row, and that gives us this. We now have the zeros above the 1 that we had wanted. Our next step is to get zeros above the next one in the next column over. So in this case, we're going to keep the last 2 rows just like they are. And we need to do row operations to get zeros up here. So to take this negative 1 and change it to a 0, we can do A plus C, because negative 1 plus 1 gives us the 0 that we need here. And then for this one down here, we can do B plus 3 times C. If we do that, that gives us negative 3 plus 3 times 1, which is 3. Negative 3 plus 3 is 0. If you do that for all of the other elements in these rows, you get this. At this point, we're really close. We've got lots of zeros down here. We've got lots of zeros up here. We've got lots of 1s on the diagonal. We need this 2 to become a 1. And then lastly, we'll need the 1 above it to become a 0. For this 2 to become a 1, we can take this row and just divide it by 2. That'll achieve the goal that we want. And at this point, we've got zeros where we want them to be and ones where we want them to be everywhere except this lonely little one up here. And the way that we get rid of this is by replacing the first row with A minus B, because 1 minus 1 is 0. When we do that, we get this. And at this point, we've got zeros down below. We've got zeros up above. We've got ones on the main diagonal. And so we are in row reduced echelon form. We are good to go. And when we rewrite this now as our system of equations, we simply have x equals 1, y equals 3, z equals 0, and w equals -2, which is our final answer. And now we can breathe.